Hi everyone, my name is Anshu Kumar and I'm one of the math experts from QMath. We are the #1 math experts community in India and we make learning mathematics fun. We at QMath enable our students to look for the why before the what of a concept, and all our students learn the concepts by themselves just by working on them. So I welcome you all to our channel, the NCERT Class 9 Math, where we will be posting videos on concepts and questions of different topics of this grade. So if you like this video, do share it with your friends, click on the like button, do subscribe to our channel and also click on the bell icon. Also, if you want a live one-on-one session with one of the QMath certified teachers, do check the links in the description to enroll with QMath. And if you register with that link now, you're going to get one free live online demo session with one of our experts. So in today's video, let's learn how to identify a polynomial, how to identify its terms and coefficients, how to find the degree of a polynomial, and also how to classify polynomials. So basically this video is going to be all about polynomials. So let's just get started. So to start with, let's consider an equilateral triangle where we know that all sides are equal. Let us consider one of the side lengths to be x. And now to find the perimeter of this equilateral triangle, we'll have to add up all the side lengths and we are going to get 3x, which is an algebraic expression. Let's take another example of a rectangle where the length is L and the breadth is B. Now to find the area of this rectangle, we'll have to multiply the length and the breadth. So we are going to get L times B, which is again an algebraic expression. Let's take one more example of a pentagon with sides SSS, V and V. So the perimeter of this pentagon would be 3S plus 2V, which is an algebraic expression. So based on these three examples, we can conclude that an algebraic expression can be formed by variables and constants using mathematical operations. For example, in 3x, x is the variable, 3 is a constant. In L times B, L and B are variables. In 3s plus 2v, s and v are variables, 3 and 2 are constants. So from here, we get two things. Number one, that variables are something whose values are unknown to us. So basically a variable can take any value. So we generally use alphabets such as X, Y, Z as variables. The second thing is that a constant is something whose value is known to us. For example, we use the numbers 1, 2, 3, pi, etc. as constants. Let's now take a look at a question of how can we identify variables and constants. So we have been given an algebraic expression 5 over x square minus 2 over y cube plus pi over z to identify the variables and constants. So basically we'll use the definition of variables and constant to answer this question. Now we see that in this algebraic expression we have three alphabets and their values are unknown to us. So basically those three alphabets represents the variables in this algebraic expression and they are x, y and z. And then we have three numbers in this algebraic expression and they are constants, which are, and those numbers are 5, 2 and pi. So basically we just have to use the definition of variables and constants to get the answer in questions like these. Now moving on, let us consider a few algebraic expressions. So the first one is 7y, the second one is x square plus 4x plus 11, the third one is z cube minus 9z square plus 11z minus 29. Now in these three algebraic expressions, we see that each of these expressions consists of only one variable. So these are also called as a polynomial in one variable. So basically a polynomial is a special type of an algebraic expression where each of the exponents of the variables is a non-negative integer. Here 7y, 4x plus 11z, negative 29, these are called the terms of a polynomial. and each of the term of a polynomial has a coefficient. For example, let us take the last algebraic expression, z cube minus 9z square plus 11z minus 29. In this algebraic expression, the coefficient of z cube is 1, the coefficient of z square is -9, the coefficient of z is 11, and the coefficient of -29, that term is -29. Now here, -29 can also be written as -29 times z raised to the power 0. But we know that z raised to the power 0 is 1. So the term is -29 and the coefficient of this term is -29. So basically a coefficient is anything in a term which is not the variable. So apart from the variable, any number or any alphabet is a constant. Now, we also have two special types of polynomial. One is, suppose we take any number, for example, 11. So 11 can also be called a polynomial. It's basically a constant polynomial because 11 can be written as 11 times x raised to the power 0. And we see that in this polynomial, the power or the exponent of the variable is a non-negative integer. So this completely is valid with respect to the definition of a polynomial. Similarly, 0 is called a zero polynomial. Now moving on, every polynomial is defined in terms of its variable. So basically we represent polynomial with respect to its variable. For example, p of x is defined by its variable x. So for example, if we take a polynomial, p of x is equal to 5x minus 9, it means that the polynomial p of x depends on its variable x. Let us take one more example. So q of y equals y cube plus y square minus 9y plus 13. So in this polynomial q of y, it depends on the variable y. Similarly, the polynomial r of u equals u square minus u plus 7 depends on its variable u. Let's now work on a few questions based on the concepts which we have just learned. So the first question, we have a set of expressions where we will have to determine whether these are polynomials or not. We'll use the definition of a polynomial to answer and identify each of these expressions. So let us start from the first one. So this can be rewritten as x raised to the power 2 minus 3, and the square root of x can be written as x raised to the power half plus 1. Now since we see that one of the variable has an exponent which is not a non-negative integer, which is not an integer here, so clearly this is not a polynomial. Let's move on to the next expression, and this can be written as -6 z square plus 5. Now the first z has a power 1, and the second z, that is square root of z, can be written as z raised to the power half. Now these two can be combined using the law of exponent. Where the bases are same, we'll add the powers. So adding the powers, we are going to get 1 plus half gives us 3 over 2 minus 9 z raised to the power 1. Now we see that one of the variable has an exponent which is not an integer. So this is also not a polynomial. So it's quite easy to identify whether an expression is a polynomial or not based on its definition. Let us look at this expression, y plus 3 over y. And this is going to be written as y plus 3 times y raised to the power -1. So here we have a variable where the exponent is a negative integer. So we clearly cannot have a negative integer as the exponent of the variable. So this is also not a polynomial. Moving on to the next expression. Now we see that 4 raised to the power 1 over 3 plus 5 raised to the power 1 over 12 is nothing but a sum of two constant terms. Now these two terms can be rewritten as 4 raised to the power 1 over 3 plus 5 raised to the power 1 over 12. Now we'll have to insert a variable here. We can only write that as x raised to the power 0 if we want to insert a variable. Now x raised to the power 0 is 1. and we see that the exponent of the variable is an integer. So this is a polynomial. Moving on to the next expression. So the power of this y is 1 and the power of the second variable is 2. Both of these two are non-negative integers. So this is a polynomial. Then with the last expression, this can be written as negative x raised to the power 3 plus 3x raised to the power 2 plus 8x raised to the power 1 negative square root of 5. Now we see we have three variables here and the power of all these three variables are non-negative integers. Hence this is a polynomial. Now you just saw that how using the definition of polynomial we can easily determine whether an expression is a polynomial or not. Let's now move on to the next question. So in this question, there is a polynomial given to us and we'll have to identify these things. So the first sub question is that we'll have to identify the terms of this polynomial. So we clearly see that there are three terms and they are negative 3 y raised to the power 4. The second one is negative 7 y raised to the power 2 and the third term is 2. Now speaking about the coefficient, so basically we can write the third term as 2 times y raised to the power 0. Now speaking about the coefficients are anything in a term which is not a variable. So the coefficient of the first term negative 3 y raised to the power 4 is negative 3. Coefficient of the second term is negative 7 and the coefficient of the third term is 2. Now they are asking for the second term. So clearly this is the second term. Hence this part is quite easy. So the second term is negative 7 y raised to the power 2. And then they are asking for the constant term. So basically a constant term is a term where you don't have any variable. So if you look at this polynomial, yes, I agree that we can write this number as 2 y raised to the power 0, but that is only when we have to represent all the terms in terms of a variable. But in the polynomial, there is no variable attached to this number. So the constant term is 2. It's basically any number where there is no variable, any term where there is no variable. So let's now move on to the next part. So moving on, we'll see the first classification of a polynomial. So based on the number of terms present in a polynomial, it is classified as monomials, binomials, and trinomials. So let's take the first one, which is a monomial. So as the name suggests, mono means one. So basically any polynomial with only one term is called a monomial. So the examples for monomials would be negative 4x squared, 11u, 33z raised to the power 5, negative 129. So all these only contain one term, single term, so they are called monomials. The second category is binomial. So as the name suggests, bi means two. It means any polynomial with two terms is called a binomial. For example, x plus 1 y raised to the power 4 plus y raised to the power 3, y square minus square root of 2. These are all binomials because they contain two terms. The third category is a trinomial. As the name suggests, tri means three. So any polynomial with three terms is called a trinomial. Let's now look at a question where how can we identify a polynomial based on its number of terms. So in this question, we have been given a set of polynomials and we'll have to identify whether they are monomials, binomials, or trinomials. Let's start from the first expression or the first polynomial. It's 100x squared. So we see that there is a single term in this polynomial. So this is a monomial. Moving on, the second polynomial, we have square root of 3 minus y plus y raised to the power 5. Now here we have three terms and three unlike terms. Hence, we can say that this is a trinomial. Moving on to the next polynomial, we again have three terms with three unlike terms. So this is also a trinomial. Now we can easily use the definition of these three categories to identify whether they are monomial, trinomial, or binomial. The next polynomial is 6 times p raised to the power 5. There is a single term, so this is also a monomial. The next expression, which is 1 plus square root of 2 plus 4th root of 3. Now all these three terms are constants. Now we know that one constant can be added to another constant. One number can be added to another number to make it a single number. So we can definitely combine these three numbers to form a single number. Hence, this will not be called a trinomial. This is a monomial. Because these are like terms, these are three numbers. So always remember this difference between a set of numbers when given together like this. Let us move on to the next expression, which is negative 2y square plus y minus square root of 3y. Now here, if we look at the terms, we see that there are two terms which are like terms where the variables are same. Let me show you that. So negative 2y raised to the power 2. If we take y common from the second and the third term, we are going to get 1 minus square root of 3. Now here we get the first term is negative 2y raised to the power 2 plus the second term is y times 1 minus square root of 3. Now inside the bracket, we can get a single number by combining the two numbers. So basically here we only have two terms and not three. So basically this is called a binomial. So basically if we have like terms, we can combine them to form a single term. Moving on, the last polynomial 1 plus z raised to the power 100 plus square root of 2 is written as, like, when we rearrange the terms and keep the constants together. So it's 1 plus square root of 2 plus z raised to the power 100. So basically here there are two terms. One is the combination of 1 and square root 2, basically a constant term, and the other one is a variable, that is z raised to the power 100. So this is also a binomial. Now we can use the definition of these three categories to identify them very easily like this. Let's now move on to the next part where we take a few polynomials. So the first polynomial would be p of x equals 7x raised to the power 7 plus 3x raised to the power 6 minus x minus 12. Now if we look at this polynomial, there are four terms. The first one is 7x raised to the power 7. The second one is 3x raised to the power 6. The third term is negative x raised to the power 1. And the fourth one is negative 12x raised to the power 0. Now, if you look at the exponents of all these terms, exponents of the variables of all these terms, they are 7, 6, 1, and 0. So the highest exponent of all the variable would be 7. So basically the highest exponent of a variable is called the degree of the polynomial. Let's take one more polynomial as an example. So q of y equals y raised to the power 6 minus 9y raised to the power 2 plus 2. Here again we have three terms, and the terms are y raised to the power 6, negative 9 y raised to the power 2 plus 2 y raised to the power 0. So the degree, the exponents of the polynomial, the variables would be 6, 2, and 0. And the highest exponent is 6, which is called the degree of the polynomial. So basically a degree of a polynomial is defined as the highest exponent of the variable. So let's take a question to understand how can we find the degree of a polynomial. So here we have been given three polynomials and we'll have to identify what is the degree of these polynomials. Now the first polynomial can be rewritten as twice of x raised to the power 5 minus 1 over 2 x raised to the power 2 plus thrice of x raised to the power 1 minus 4x raised to the power 0. Now we see that there are four variables and the highest exponent of the variable would be the degree. So which is clearly this. Hence the degree of this polynomial is 5. So you just saw that it's very easy to use the definition to get the degree of a polynomial. Let's move on to the next polynomial, which is x plus pi raised to the power 3. And this can be rewritten as x raised to the power 1 plus pi raised to the power 3 times x raised to the power 0, because pi raised to the power 3 is a constant term. So just to write that in terms with a variable. So this is what we are going to get. Now here, if we look at the two exponents of the variable, the highest is this. Hence, we can say that the degree of this polynomial is 1. Moving on to the next polynomial. And we see that here, this polynomial is a combination of two terms with variables and two terms that are constants. But we know that degree of a polynomial is the highest power of the variable in a polynomial. So basically, the two terms with variables are these two terms, and the highest power would be this. Hence, the degree of this polynomial is 25. So you just saw that it's very easy to identify the degree of a polynomial. So now let's move on to the next part, where based on the degree of a polynomial, it is classified into three categories: linear, quadratic, and cubic. Let us consider each of the categories one by one. So the first one is a linear polynomial category. For example, f of x equals 2x plus 4 is a linear polynomial where 2x is the linear part and 4 is the constant part. And in this polynomial, the highest power of the variable is 1. That is why it's called a linear polynomial. The second category is quadratic polynomial. So any polynomial with the degree 2 is called a quadratic polynomial. For example, g of x equals 3 minus 2x plus 5x square, where 3 is the constant part, negative 2x is the linear part, and 5x square is the quadratic part of the polynomial. And the degree of this polynomial is 2. The next category is the cubic polynomial category, in which the degree of the polynomial is 3. For example, p of x equals x cubed minus 6x square plus 11x minus 6, where negative 6 is the constant part, 11x is the linear part, negative 6x square is the quadratic part, and x cube is the cubic part. And we see that the degree of this polynomial is 3. Let's now look at a question based on this concept. So basically, we have been given a set of polynomials and we'll have to identify whether they are linear, quadratic, or cubic polynomials. So we'll use the definition of these three categories to identify whether the polynomials are linear, quadratic, or cubic. Let's first work on the first polynomial. So we have three constant terms. So negative 2, square root of 2, negative square root of 3, plus square root of 5. These three are constants. So these three can be combined to form one term, plus square root of 11y. And the power of this variable is 1. So we know that the highest power or the degree of the polynomial is 1, and it is called a linear polynomial. So hence this is a linear polynomial. Let's move on to the next polynomial. So in this we have a negative 1 plus z over pi. There is only one variable, and the power of this variable, this polynomial can be rewritten as z raised to the power 1 over pi. Since the highest power of the variable is 1, it is called a linear polynomial. In the next polynomial, we have three terms. And if we rewrite this, we are going to get z square negative square root of 2 z raised to the power 2, because this is the constant term, plus square root of 5 z raised to the power 1. Out of these three terms, the highest power or the degree of the polynomial is 2. Hence, this is a quadratic polynomial. In the next polynomial, we have four terms. So these can be rewritten as negative 4x raised to the power 0 plus 1 over pi x raised to the power 3, negative 0.9 x raised to the power 2 plus 1 over 2 x raised to the power 1. If you look at the powers of the variable, we see that the degree of the polynomial is 3, hence this is a cubic polynomial. In this next polynomial, this can be rewritten as negative square root of 3 over 10 x raised to the power 0, negative 7 x raised to the power 2. The degree of this polynomial is 2, hence this is a quadratic polynomial. And in this last polynomial, negative 4 over 9 whole cube times x raised to the power 0. We'll rewrite this as this because we are representing it in terms of a variable along with a variable. So plus x square. Now the degree of the polynomial is 2. So this is again a quadratic polynomial. Now we see that how we can use the definition of linear, quadratic or cubic polynomials to get the answer. So we can easily solve these questions. So this is it for this session. We have covered all the concepts which help us understand the basics of polynomials, and based on this we are going to solve some advanced level concepts, and we are going to use them to solve advanced level questions. So this is it for this video. You can use these concepts and methods to solve questions from your textbook. And if you have any queries, any doubts, you can post it in the comment section below. We'll be very happy to help you out and to reply back to you. So if you like this video, do share it with your friends. Click on the like button. Do subscribe to our channel and also click on the bell icon. Remember, if you want a live one-on-one session with one of the QMath certified teachers, do check the links in the description to enroll with QMath. Also, if you register with that link now, you're going to get one free live online demo session with us. Do have a good day. So it's bye-bye for now.